Good morning, everyone. Welcome to this webinar and thank you for joining us today. The reason why we decided to do this webinar is because the 1st of April 4G was launched in Turkey. We know that upgrading in building networks from 2G or 3G to 4G is not always easy, and we want to give you some tips and hints to help you doing this. Next. Before starting, let me go through a few housekeeping items. All you will be muted during the webinar. You will receive the slides of the webinar as well as the video recording in the next few days. And if you have any questions during the webinar, please ask them using the GoToWebinar question box that you will find at the right side of your screen. After finishing the webinar, we will go through all these questions. Next. Let me go very fast through the agenda. First of all, I will be doing a fast presentation of iBwave for those who don't know us or don't have updated information. First, I will be doing a company presentation and then a fast product portfolio presentation. But don't worry, this is not a sales presentation, so it will take only a few minutes. Then Robert Foyer, who is the sales director for EMEA, will talk about IBS drivers, indoor versus outdoor, and worldwide trends. And finally, Jalal Barahu, who is the sales engineer director for EMEA, will talk about 4G challenges and best practices, LTE case studies, and finally he will go through all the questions and finish the webinar with a few closing remarks. Next. Next, please. Okay. Even I know most of you. For those who yet don't know me, I am Francisco Campins, iBwave sales manager for Southern European countries. I joined iBwave about 5 months ago, so if we didn't have the chance to meet already, don't worry, because we will meet soon. Okay, so let me briefly talk about iBwave. iBwave was founded 13 years ago with the purpose of providing to the market a set of tools specific for designing and documenting in building networks. Since the beginning, iBwave tools had a huge success in the market, with more and more customers adopting our solution each year. Actually, iBwave is the worldwide standard for in-building network design and documentation. We are trusted by more than 800 customers who are using our tools in over 90 countries. We are continuously innovating, investing a lot of resources every year to improve our tools with new functionalities and capabilities. In 2015, iBwave was purchased by Corning. Corning is a huge technology company. It is one of the 300 largest companies in the world. It is based in the United States. It has 150 years old and has over 35,000 employees. Next. During these years, iBwave has come up with a set of tools that cover all the life cycle of the in-building networks. All our tools are designed to speed up the network design and documentation processes, as well as to improve the quality of the networks. In iBwave, we provide mobile tools that can be used in a first stage to do site surveys. These mobile tools will be installed in an Android tablet. We will load the floor plan of the venue, and then we will be able to geolocate in this floor plan all the pictures, notes, voice recordings, etc. Once we leave the venue, all the site survey documentation will be automatically created and sent to the office. This will save a lot of time. We can even do a small sales design directly with our mobile tools. This can dramatically speed up the time to market for small and medium venues. Once we have the site survey documentation, it will be automatically synchronized with our desktop tool, iBwave Design. With iBwave Design, we will be able to do a complete design of the in-building network. We will be able to simulate the propagation of the signal, getting of kind of results like signal strengths. We will be able to simulate how the macro network or other networks are interfering our in-building networks, having RSRP, RSRQ, or even throughput measurements. And we will be able to import measurements from third-party equipment to our designs. Once we have the design, we will be able to generate any kind of report, like the bill of materials, to send to our vendors. With these designs, the installers will have all the information they need to do the installation. Once the installation is finished, we could go with our mobile tools to the venue to check if it has been done according to the design. If there are any changes, we will be able to document them with our mobile applications that will synchronize the information with our desktop application and automatically will generate the as-built documentation. We have also our Unity platform. Unity is a management solution that can, where you can upload all your iBwave projects. Unity will read all these projects and will automatically generate a database containing all the information regarding each project. You will be able to do any kind of advanced queries, like, for example, how many venues have not been upgraded to 4G, how many Catherine antennas we have in metro stations in Istanbul. So you can have in seconds very useful information to make the right decisions. Unity also has the workflow module. It is a project management module that allows you to easily follow the status of all your in-building projects. You can see in which phase of the project you are, you can see who is responsible for each task, you can see if the project is on time or if it is late and why it is late, etc. It is a very useful tool for managing purposes. We have also our training and certification programs. We offer 3 levels of training, and right now we have more than 4,000 certified engineers. In some countries, operators mandate that the subcontractors doing in-building projects are iBwave certified as a way of proving that they have the required in-building knowledge to do these designs. Finally, we have our components database, which has more than 20,000 components modeled. These components have been modeled mostly by the vendors themselves. Each week we receive around 150 new components to add to the database. In this database you will find most of the components that are available in the market, and you will be able to add them to your projects without the need of modeling the components yourself. I don't want to go much deeper in our product portfolio since this is not the purpose of the meeting. If you have any question, please just contact me. So now Robert will continue with the next point in our agenda, the iBwave drivers. Thank you very much. Next.
Thank you very much, Francisco. This is Bob speaking, and what I would like to do now is take a little bit of time to look into the drivers for the adoption of LTE and the deployment of LTE indoors. First of all, it should be recognized, and I guess Turkish operators are on the front line for this, that demand for mobile data is driving upgrades and innovation throughout the world. This is driven by the adoption of smartphones, which are generating significant traffic requested by end users who are video streaming, downloading emails, retrieving documents, doing conference calls. I remember, as an example, several years ago I was visiting a customer in Turkey who showed me something that was quite innovative. I think it was five years ago already, that you could check the traffic on Istanbul highways from your smartphone to plan for your trip. And you know more than us what it takes to go from one point to another in Istanbul. And this was live streaming video from traffic cameras. This is something that is, again, driven by the smartphone adoption. And if we look at the market in the world, the picture on the right-hand side of the screen maybe is not exactly up to date, but it shows that currently there are roughly 1.4 billion smartphones, whereas there are still somewhere around 4 or 5 times more, let's say, regular old days GSM phones that typically could be migrated to be replaced with smartphones. So imagine the traffic explosion that this will generate on top of what already exists. Mobile data is requested pretty much everywhere, but of course if we now look into the next slide, we can see that one of the strong drivers is in building. we see the next slide, please? Indeed, when you do emails or voicemail or any other data-hungry application, many times you will be indoors. And as you know, for many years, radio network planning has been done from the perspective of outdoor coverage, but it turns out that data is consumed primarily indoors, be it in shopping malls, airports, subways, or office buildings, not to mention residential, of course. So what we see happening is the more people adopt smartphones, the more congestion there is on networks, and this is driving further adoption from customers, and in the end, operators have to match that demand, and this leads them to focusing further on where the demand is coming from, residential and enterprise customers. To address that, one needs some tools, and this is what we will be presenting today. But before we do that, I would like to go through a few slides, and then if you can please move on to the next slide. I'm going to elaborate on what is happening in the rest of the world. Indeed, everything I've said so far concerns Turkey, but the good news is that it's a general trend we see all around the globe, and therefore there is probably a lot to learn from other people's experience, other countries, other trends. So starting with Europe, today we will focus on Turkey, but generally speaking, we can see that Europe is quite diverse. Whether you're looking at the, let's say, the western part where 3G and now 4G are commonly deployed, to the north of Europe, typically, the Scandinavian part, which is land to Nokia and Ericsson, where a lot of innovation takes place, where LTE has been deployed for 6 years, if not more. Actually, I think Sweden was the first country in the world to have LTE deployed at a time when even smartphones were not ready for LTE. Companies would have to buy a USB dongle to roam on the LTE network when it was introduced back 6-7 years ago. So the interesting thing here is that we can benefit from the experience acquired by those different players, whether operators or also equipment vendors, which are on the front line when it comes to innovation. Eastern part of Europe, we've seen very diverse situations. 3G is mature, but LTE is not completely widely adopted yet. It is getting there, and if we can look at Turkey as part of this eastern part of Europe, then as you know, LTE is now here. It is happening. So generally speaking, I would say Europe is fairly widely on LTE, but at different stages and different speeds of deployment. Next slide, please. The next slide has to do with Africa. Africa is a territory where we see a lot of momentum for in-building, but here again, LTE is not there yet in many places. What seems to be driving the business there has to do with large and complex venues such as new airports or luxury malls. And we see a lot of interest in the neutral host approach. We can discuss that further maybe on this call regarding Turkey. The concept of neutral host is not popular everywhere, but it is gaining momentum. In Africa, the leading countries for in-building are the countries in the northern part of Africa, and then if we look at the southern part of the continent, it is primarily South Africa and a few countries such as Nigeria, Kenya, Tanzania, Ghana are leading the way. Most of the time, investments are made with the latest and greatest technology, as there are many places where the networks are built from scratch. Next slide, please. So the next slide, we're talking about the Gulf countries. The Gulf countries are an interesting combination where you have both large buildings, a lot of them, usually some solid funding, and also a habit of importing best-in-class technologies and know-how. And not to mention the fact that most of the business and life takes place indoors for obvious reasons. At the moment, we see tremendous amounts of projects. Projects have been completed before, but now we see a lot of momentum also with the 2022 World Cup, the 2020 Expo in Dubai, and fancy projects like the largest tower in the world being constructed in Saudi Arabia. So all these lead operators to investing significantly into LTE and Wi-Fi, also with a target to deploy what is referred to as smart cities. This is a very significant topic these days. Next slide, please. So in the next slide, we address Asia Pacific. Asia Pacific is a very, very diverse part of the world. It's not a continent even, it's several continents. And as can be seen here, you can distinguish very large and different countries such as China, where voice is still the key driver, but we see DAS is coming up as being more and more popular, but there is a lot of optimization to do, as this was disregarded for a long time. At the other end of the spectrum, Singapore is extremely focused on delivering best-in-class coverage and throughput, data rate, speed in any particular venue, whether it's in the shopping mall or in the toilet of an office building. There is a strong demand for speed, and therefore operators are putting a lot of pressure on deploying those technologies and sometimes deploying innovative technologies like small cells. From the Southeast Asia point of view, Indonesia, Thailand, Philippines, here we see a lot of in-building activity with endeavors towards neutral host solutions, but LTE is not as widely adopted as it is in other parts of the world. So this is an area where we see significant LTE growth for the future. Next, please. Australia, New Zealand, or some will refer to this as Oceania, where we see the encouragement of a neutral host approach by the regulators. Most operators are strongly focused on in-building, and interesting enough for Australia at least, there is an enforcement of documentation sharing between operators through a platform so that all information pertaining to indoor systems can be retrieved in a easy fashion. However, we see also a change in the ecosystem as the roles between operators, system integrators, and equipment vendors are changing, probably driven by the neutral host push. We only have another couple of slides, so now if we can switch to the next one, which is North America. North America for iBwave is a bit like our backyard because we were born in Canada. We see that LTE has been the trigger, the tipping point for indoor deployments. Indeed, with the introduction of the iPhone by AT&T, there was immediately a dramatic impact on the outdoor network of that operator. The network collapsed within a matter of weeks. So there was, in the early days, a strong focus on improving indoor coverage, and this was the trigger for LTE to be rolled out in that country. Several SIs are offloading their work to smaller ones, whereas different technologies are being deployed. DAS is obviously a key one, particular active DAS. Neutral hosts are quite common, but there are more investigations now into small cells and also Wi-Fi as an offload solution. For example, Google has launched a roaming subscription where if you are outdoor on a cell phone, you can roam on Google Wi-Fi when you go indoors in a seamless fashion. In Canada, it's a different story. Up until now, operators were doing everything themselves, and we see a trend for the system integrators to take over some of the designs and even site management contracts. And now there is a focus on finding lower cost alternatives to DAS. I think the key thing here to note is that there is never a definite technology. There is always a momentum towards combining technologies, for example, LTE with Wi-Fi. And to conclude with CALA, on the last slide, please, Central America, Latin America. Here, what we see is that migration to 3G and 4G is happening as we speak. This is driven in some places by major events like the World Cup. This is already 2014, but then the Olympics in Brazil this year. Now, the fact of the matter is that spectrum and devices are quite expensive, and as you probably know, there is also a currency crisis in CALA at the moment. So operators are focusing on optimizing their investments. The way they're doing this is by having a preference for passive systems. There is little focus on neutral hosts, but they will work on neutral hosts when the cost justifies for like major events. And you see a few names of top operators like América Móvil or Nextel, for example. What's important to see here is that several of those are trying to replicate the success that AT&T has had in the US addressing the enterprise market by having dedicated teams to deliver indoor coverage systems in a timely and cost-effective fashion. So this ends my part. The conclusion of my part is really that, as you can see, LTE is being adopted or has been adopted globally. It's always driven by the same trends that operators need to deliver speed to their customers, especially the enterprise customers. And we foresee that Turkey, being now in the 4G club, if I can say, will most likely face the same issues. And I am certain that you have already planned for a lot of those issues. And on our side, we would like to take this opportunity to expose you to some of the challenges that we have identified, and maybe we could help our customers with those challenges. So I will now let my colleague Jalal take on the presentation from this point. Thank you.
Thank you, Francisco, for the introduction, and thank you, Bob, for going over the trends worldwide. Now, I would like to highlight some of the challenges and best practices related to LTE. And again, iBwave, with presence globally, we have worked with many operators, with many of our customers that have deployed LTE, and we've been more than happy to share the experience with the operators and the system integrators and vendors in Turkey for sure. With regards to LTE, so LTE is based on certain modulation schemes like QPSK, 16 QAM and 64 QAM. What is to note about LTE is it can provide very high data rates, up to and even more than 100 megabits per second. But again, being able to achieve those data rates need certain parameters to be met, or certain conditions, I would call them, like interference being taken into account, having a strong signal indoor, and how to do the deployment itself. Covering a building from outdoor sites is probably not the best option for LTE, and we will see why in the next slide. But what is important to note is within an outdoor macro cell, you have coverage zones, and if you have a building or you have an area where you have covered previously at let's say between 1 and 10 megabits per second for outdoor users, if you have a user within indoor premises, then the call the coverage will drop to the lower level, and most likely they're not going to have access anymore to data, or they're not going to have very good coverage. Same thing with users that are very close to the site, so they will not be able to achieve the same coverage or data as an outdoor user, so the coverage will drop again because of penetration losses inside the building. So with LTE specifically, the intention to cover indoor users used in macro sites is probably, does not really work all of the time. So the reality is we have to have a proper indoor DAS that can serve the both coverage and capacity of the indoor users. Now, some considerations that are applicable actually to both 3G and 4G, and even more importantly for 4G. These technologies are able to achieve very, very high data rate when they are designed properly. What we mean by designed properly is this is not like the older technologies like GSM, for example, where the main concern back then was more for voice. So people were usually talking on the phone. So when we were planning an IBS or we were planning coverage, we would have to take voice into consideration. But with LTE, it's the design criteria has shifted from voice to data rate and capacity KPIs. For example, with LTE, the majority of the users will be using that technology for video streaming or for data download or video conferencing, for example. So for voice, we would plan for 8.8 kilobits per second bandwidth, but then for data rate, you could have to plan up to 2 megabits per second per user. So again, that will eat up a lot of the bandwidth from the capacity, and it will require us to even provide more capacity to be able to accommodate all the user profiles that we have within a certain venue, for example. Another, to be able to achieve that data rate and capacity, we need to create dominance inside the venue, and the reason is because we will have some outdoor interference coming from the macro network. And we have to overcome that to be able to ensure that we have a very good signal-to-noise and interference ratio, and which will allow us to have a much greater data rate and capacity provided inside the venue. Optimization, again, during the design phase will save us a lot of time and cost, because if we don't do it at the initial design and planning phase, then we will have to face the optimization part after implementation, which is, again, very costly. And that's the case study that I will be able to show after the slides, which is actually a real example that we were involved in. And I'll show you how the optimization can be done during the design phase instead of after the implementation. Now, how do we manage interference from the outdoor macro network? Well, if we look at the interference scenario first, we have outdoor sites within a certain, let's say, neighborhood or a certain city. From outdoor planning tools, so we know what kind of coverage we have from the LTE sites, and it might show that we have adequate coverage everywhere around the buildings. But the fact is, once those signals penetrate inside the building, then we have the wall losses, and that will reduce the coverage or reduce the signal level that we have coming from the outdoor signal. This is what we call the residual macro signal inside the building. Now, most of the time, we have to do a walk test to find out exactly how much residual macro signal we have inside the building. And once we have that information, then we can plan for the signal dominance inside the building. We can plan to limit the sector overlap to the least occupied areas, meaning the areas that are not frequented by users a lot, and avoid the areas that are very high traffic, where there is high traffic. We can make sure that in the areas with higher density that we place the antennas closer to those areas. And then, depending on the user profiles we have inside the venue or inside the let's say each floor plan, we know now how we can do the sectorization for capacity to be able, again, to accommodate the different user profiles, whether they are on voice, on email, on video conferencing, on data download. So we have different user profiles that we have to accommodate through the sectorization part for capacity. And again, this is a little bit different because when we do 2G or even 3G, we have a certain number of sectors that will be enough to cover all the user profiles that we have. For 2G, mainly for voice, so you might need just one, let's say, base station to cover a building. But when you upgrade to LTE, then you have to make sure that you have enough sectors or enough sectorization to be able to, again, accommodate all the users that are inside it, and it will be different between 2G, 3G, and 4G for sure. Another thing to keep in mind is that it depends on the LTE frequency. Again, some countries, they have deployed in the lower frequencies, such as in the US, where they have deployed LTE in the 700 megahertz, for example. And these, they have, let's say, the penetration inside the building is much better than the higher frequencies. But the problem is, when you have a low frequency, then the signal travels even further. So you have multiple macrosites coming in at the same time at a certain point, let's say. With other countries, such as in Middle East, for example, in UAE, they're deploying at 2.6 megahertz. So this is a high frequency for LTE. And when you have that, then again, the penetration losses inside the building are much higher, and the signal travels much less than in the lower frequencies. So there are two different frequencies, usually the higher and the lower, that each one has its own challenges, of course. In terms of how we can take the different parameters into account and how we can analyze maybe the coverage, let's say, and how to plan the IBS deployment. So if we have a floor plan where we're analyzing the coverage from the outdoor sites, then we can see that we have, well, RSRP, which is the reference signal received power. This is a parameter more related for LTE. From the outdoor sites inside the floor plan, we analyze the residual macro network, and then we'll know that we have very poor coverage from the outdoor sites. That translates in a very low data rate inside the building, right? So if we look at the RSRP map with low signal inside the floor plan, it translates into QPSK at the most inside the floor plan, again, because of we have a very weak signal confirm outdoor. So some of the planning options that we have, the traditional method was to placing antennas in the middle of the floor plan, and then you cover the whole floor plan pretty much based on that antenna placement that you have. Now, with that traditional approach, you can see that well, it's true that the signal level is actually pretty good inside the floor plan. So if we base our planning just on the signal level, then we're probably going to meet the KPI of signal strength of, let's say, minus 85 dBm at 95% of the area. That shouldn't be a problem. So on paper, the KPI is met. But the problem is that when we look at the data rate, we will still have a low data rate. I mean, we'll be able to achieve a little bit better than the outdoor signal, but the problem is that it's still lower data rate. And the main reason is because we have not created dominance inside the building over the macro network. So the signals are very close to each other. You still have a lot of interference coming in from the different outdoor sites, and that will cause very low SNIR, and which will cause very low data rate. And again, at the end of the day, LTE is not going to provide us the data rate that it has in commercial use, which we would like to achieve to retain the customers. A different approach when planning LTE, as we mentioned earlier, is to have the antennas closer to the high-density users, or to create dominance over the macro network. One way of doing that is placing the antennas closer to the edge of the building, and that will give us, again, a very good signal strength. But what it will do now is it will create a much higher dominance than the outdoor macro network. And that translates into a much higher data rate, again, because we have improved the SNIR conditions inside the floor plan, and that gives us much better data rates in the 64 QAM modulation scheme instead. Now, with LTE, LTE had, as a technology, introduced new concepts and let's say new key performance indicators that we were not using before. Some of those parameters that are widely in use are the RSRP, which is the reference signal received power, and then we have the RSRQ, which is the quality of the signal. And then we have again the SNIR, the physical downlink shared channel SNIR. Now, if we look at the ISRP, so this is similar to the pilot power in CDMA. The reference signal is the main parameter in LTE, and that's what we have to base our planning on. So we have to take into consideration the reference signal, and then we have to make sure that we meet the KPI for the receive power and the receive quality to meet the KPIs for LTE. In terms of requirements, so the requirements are similar to 3G, for example, where we need to have a very clean quality, which translates into a significant RSRQ inside the floor plan. We need to have an RSRP signal, which is dominant inside the floor plan, and it should be several dBs higher than the macro residual signal. And I'll show some examples of what the values could be. We need to make sure that the overlap between the indoor and outdoor area is managed properly. So we need to have minimum spillage outside the building into the macro network and vice versa. We need to manage the interference from the outdoor. We need to minimize the handoff between the different B sectors, as again, soft handoff is not applicable in LTE. We need one important note is MIMO, and maybe in this particular case, Turkey will benefit a lot from different experiences worldwide, where in some countries MIMO has been deployed on every single LTE rollout, but the problem is that MIMO does not necessarily always provide double, let's say, the bandwidth, or double the data rate. So being able to deploy MIMO more efficiently where it provides the highest advantage is key, and there are ways again on how we can check if MIMO is able to deliver as promised. Again, one very important aspect is how to accommodate and sectorize for capacity. So again, LTE, the main purpose is serving user profiles that are very high demanding in data, and we would like to make sure that we sectorize and we accommodate those users again to be able to download and to be able to do video conferencing and any other applications that are needed. Some of the examples from LTE building considerations, let's say globally, and again there was maybe a little bit misunderstanding in the beginning where some of the KPIs mentioned that the RSRP should be similar to the other technologies, and some of the some maybe designers, they would plan for -75 or -80 or -85 dBm, but again for LTE that's not the right way to do it. So the RSRP should be greater than -95 dBm. Or it should be 5 to 7 dB greater than the residual macro network again, and that's how we can provide. We can have a very good signal strength, but we also have created dominance over the outdoor network. RSRQ, the main recommendation is that it should be -5 dB at 50% cell loading and 85% orthogonality. Again, that's recommended quality value to have a very clean signal inside the floor plan. And then we have the signal to noise interference ratio, and these are dependent. The values for this are dependent on the NCS index, coding rate, and efficiency, and these values are already integrated into iBwave design depending on the modulation scheme. So QPSK, 16-QAM, 64-QAM, each one of them has different parameters. They're already configured in iBwave design if you would care to take a look. Now what I would like to do is maybe go through a case study, and again, as mentioned earlier, this is an actual case that happened with one of our customers, mainly in Southeast Asia, where they had let's say an LTE deployment, and they upgraded an existing network, and then after deployment, they realized that they're not meeting the KPIs. So we had to analyze why the mistakes that were made during the planning phase, and we had to fix the situation again. First thing to keep in mind is that when doing LTE deployment or upgrade or even planning new sites, we have to take into account the different requirements and criteria that are present. So each operator will have its own guidelines and design criteria. So if we're designing for multiple operators or even a single operator, we have to make sure that we take into account the different services that should be provided. So for cellular, for example, is 2G, 3G already present? We want to upgrade and include 4G, or do we have to create a new one with all those technologies? What about public safety? Wi-Fi offload, for example, is this something that we need to consider? And then for each of the services that we have provided, we have minimum requirements such as the KPIs, the RSSI, the SNIR, the RSRP, and RSIQ for LTE. So how much data throughput we would like to provide. And then we need to make sure we take into account the capacity requirements. So the market share, how much capacity we are providing, how many users we have, the user profiles that we have. So it becomes very, very complex to manage all of the requirements and criteria. So the proper way of the recommended process that iBwave would like to suggest is, first of all, we need to make sure that we know what is the outdoor signal coming inside the floor plan. So we need to understand how the outdoor network interferes with our indoor network before we even deploy. So once we know the condition of the outdoor signal, we can create what we call an interpolation map to find out the exact signal level inside the floor plan. And then we do a design of our indoor IBS system. And once we do that, then we can generate the signal from the indoor and then the noise interference, the noise of the system, and then the interference from the outdoor. And this will provide us with an SNIR map, signal to noise interference ratio map. And based on that information that we have now, we can generate a data rate map, which will tell us exactly how much data we are providing in each part of the floor plan. So again, it might be that the signal level within a certain area is very good, but then again, when we do the data rate in SNIR, we find out that some of the users in that particular area will not get proper coverage, again, depending on the profile, the user profile, the application they are using. Now, for the case study, I would like to mention, we have, I have a couple of examples actually. Again, this is a real-life study that was done in the past. This is a tower of multiple floor plans, and we have considered two different scenarios. So we have considered the lower level and then an upper level, higher level. It is, again, true that the lower levels usually have very low interference, maybe no interference depending on, again, on the interference conditions, but then the higher you go inside the building, the more line of sight you have from the outdoor sites and the more interference you're going to have. So the higher you go in the building, the higher interference you will have. Now, taking a look at the lower level, and in this example, we took a level 11 analysis where we had an existing network with 4 antennas, and then again, if we don't look at the interference, then we have a very good signal strength inside the floor plan. That means the KPI. We are passing minus 85 dBm at 100% of the area, and then we have a very good SNIR condition. So again, we are passing the criteria for SNIR conditions. And then when we look at the data rate based on that, then we have, again, we are providing very high data rate. So in this example, 16 QAM throughout the whole floor plan. Now again, the problem is that when we did this exercise, or when the engineer did this exercise, they did not consider the outdoor signal. So after deployment, this is what they should have received, but after deployment, they found out that actually that's not the case. They had a lot of issues of connections. They had dropped calls in certain instances. They had very low data rate. So what we did is we made some measurements inside the floor plan, and now we were able to import those measurements inside the floor plan, as you can see here. So this is the survey data that was conducted, and we were able to see how much interference we have coming in from the outside. And this changed the results of the SNIR and the data rate, of course, because now we have real interference coming into play. So the SNIR dropped dramatically in certain places of the floor plan, which reduced the data rate. So again, instead of having, let's say, the highest data rate all over the floor plan, so it dropped dramatically in certain, closer to the edge of the building, of course, where you have high interference. So this, again, changes the way we should be doing design and planning. This is, again, low interference. Now, If we look at a different floor plan, which is a much higher floor plan, so we're talking about a level 28 in this example, and again, this could be a floor plan where we have high interference. So the first thing that we noticed in this planning is that each floor from bottom to top was designed the same way. So all the antennas, they were placed in the same locations, the same number of antennas per floor, meaning that, again, designing one floor is similar to, it should be the same as all the other floors, and the same design was done. But again, this is not really true when it comes to LTE planning. So it could be that the lower floors with low interference, you could have a minimum number of antennas as this one here, but then the higher you go, the higher interference. So you should do a better optimization, and you should be able to do better planning with those in areas where you have high interference. So in the upper level where we have high interference, so again we did the same exercise of collecting measurements inside the floor plan. And as you can see here, so again we have higher interference coming in from the outdoor macro network. So again, closer to the edge of the building, we had a residual outdoor signal of minus 65 dBm in this example. And then closer to the center of the building, we had the signal dropped to minus 80 and then minus 85 dBm. But again, this is why it's recommended to take that into account, because now that we have the interference analysis, what we're able to see is an SNIL conditions that are dropped again dramatically close to the edge of the buildings, and even in the center of the building again, because now we have higher interference in the outdoor, and that translated into again a data rate that is even lower than the lower floors that we saw before. And there are instances in the building in the floor plan here where it dropped to even the lower level data rate QPSK, and we are not able to achieve the same KPIs that we had before. So keeping an eye on that interference analysis is again very key when planning for LTE deployments. Now, in terms of optimization, so how can we take optimization into account during the planning phase and do it right from the start? Now, there are different ways, again, of doing optimization. So one of them, and again, it depends on whether you have an existing design that you upgraded or you have a new design, but increasing the output power of the antennas, if that's a privilege that you have, where you could inject more power into the IBS. With that, you'll be able to have a much better signal strength inside the floor plan. And again, that will give you a much better SNIL conditions, and in turn that translates into a much better data rate. So again, having the ability to have better signal is one way of improving the conditions inside the floor plan. Keep in mind again that if you have to do capacity planning also for LTE, so it's going to be different for the other technologies. So when you sectorize, if you're doing a passive DAS throughout the building and you do sectorization, then for sure you will have much more, you'll have more signal power for each sector because you'll have less losses from the passive equipment. If you're doing, let's say, an active DAS where you have active equipment, then that's not something you have to worry about in terms of losses of the passive equipment. But again, you'll be able to do, to control how much power you have at the antenna level, and you'll be able to see exactly how you can optimize for better coverage at the antenna level. This is one way of doing it, but the majority of the time that's not probably the most available option for the designers to do optimization. So again, it remains depending on the interference level. For the higher level floors where we have higher interference, then sometimes it's better to add more antennas closer to the edge of the building to be able to again provide dominance over the outdoor macro network. And this is probably one of the key criteria when upgrading, for example, from 2G or 3G and then to 4G. Again, if you have, especially if you're deploying on the higher frequency, 2.6 or 2.1, then depending on the user profile, again, you'll have the signal will travel much less than the lower frequencies, of course, and you'll have a much smaller coverage area from your antennas. So to compensate for that, you'll have to add, let's say, more antennas. And again, depending on the sectorization, you might need one sector for 2G, but you might need, let's say, 4 sectors for LTE for capacity planning. In which case, so how do you combine the 2G and LTE, for example, based on different sectors? And again, this is not a case study that we could look into that happened with the real customer in Asia as well, and I can share the details in a different session. But again, being able to having the ability to do optimization during the design and planning phase will definitely save you a lot of time instead of having to wait for implementation. As mentioned earlier with the customer that I had in Southeast Asia, unfortunately for them, they had to do optimization after implementation. It was very costly in terms of time, of resources that are needed, and it's something that could have avoided much earlier during the design and planning phase. So having said that, I would like to close the chapter with the note that LTE planning is much more complex, of course, than the previous technologies. In order to properly plan and design for LTE, we need to look at the interference. We need to look at different KPIs that are needed. The criteria, the requirements are different. So being able to have tools that will help with the planning and optimization during the design phase will definitely save you a lot of time as engineer, and also having the proper training to do LTE design and planning is a key factor in doing a much better job at an early stage and having a very good IBS LTE deployment moving forward. So with that, I would like to conclude that session on the challenge and consideration in the case study. And now what I would like to do is open some of the questions and provide some of the answers to the questions that were posted. Amna?
Thank you, Jalal. We do have some questions. I would just like to remind everyone, if you have questions, you can type them into the questions box, and we'll get to them if there is time. So the first question that we have is, what are the typical coverage targets for LTE?
Okay, thank you, Amna. So I think I answered that question already, as we mentioned earlier. So let me just go back to the slide to highlight the different criteria KPI for LTE. And again, I hope that answers the question. So we mentioned that LTE, there are different parameters that need to be taken into account. One of the parameters is the RSRP, the reference signal received power. So again, the requirement is usually minus 95 dBm at a certain, let's say, 95% of the area, or to create dominance, usually we have to pay attention to how much greater the RSRP indoor is over the outdoor RSRP, and the recommendation is usually 7 dB. So make sure you have your RSRP indoor 7 dB greater than the residual RSRP. Another key KPI is the RSRQ. As mentioned, it should be minus 5 dB at 50% cell loading and 85% orthogonality. And then SNIR conditions, and again, it depends on different parameters. So it's not like the other technologies where you have a value, but now we have different parameters that are taken into account, like the NCS index efficiency and then the coding rate. Again, a lot of these examples are provided in iBwave design. And their project properties, network optimization parameters, you'll be able to find based on each modulation scheme what the parameters should be.
Thank you, Jalal. So the next question is, does iBwave support voice over LTE?
Very good question. So this is something that has been recently added to our features in iBwave design. So the ability to properly plan for voice over LTE is now available in the latest release of iBwave. I don't remember the exact version number, but we will check that, and when we provide our answers to all the questions, we will make sure to include detailed information about voice over LTE in iBwave design.
Thank you, Jalal. So there is another question. Can iBwave help tackle PIM issues in LTE?
Well, PIM issues, yes, we have capability of analyzing PIM specifically. Well, PIM, for those probably that are not very familiar, so it's a passive intermodulation, which is again, because of the wording, it's applicable more for passive systems, passive DAS. And I would say that PIM is not related just to LTE, but it's related to any other technology, and it should be taken into account when doing the planning. So again, it's a much bigger topic than to answer in few minutes. Okay, so just briefly, what we have done in iBwave design, we have actually gone through the database of components that we have for all the passive equipment. We have updated all the information that we have with, there's always an intermodulation rating for each passive component. We have included that in our database of components. And when you do a design now, when you include passive equipment, you'll have the ability to set a threshold of how much PIN you can, let's say you should have, and iBwave design will automatically check the components that you have used if they meet your criteria or not. Some of the recommendations in the industry is that the PIN rating should be minus 160 DVC for passive equipment, or minus 140, but it should not be higher than that. This is to ensure that you can manage your PIN, the components PIN adequately. But it's not just the component. PIM is not related just to the components or the design part, but it could also be part of the installation. If you have rusty equipment or the connection between the connector and the cable is not done properly, that could generate PIM issues. If you have multiple frequencies at a very high power, let's say, inside in your DAS, injected in DAS, that could cause a lot of PIM issues. So again, there are many different parameters that affect the PIM. The part that affects that is related to the equipment is already part of iBwave design. We handle that, and then we also have a report actually that shows the compliancy, but also the PIM compliancy. So this is a report available inside iBwave design, and again, it's a new feature that we have added. So for maybe detailed PIM analysis and how to deal with PIM in a passive DAS, maybe this is something we could have a separate call just to make sure we address all of the different parameters that affect the design or the DAS that are based on PIM. Thank you, Emma.
Thank you. So let's just go one last question. Will iBwave support LTE-U?
Yes. So again, this was probably a recent addition, and actually, if I think about it correct, we do support LTE-A, LTE Advanced. This is something that we have included, I think, last year in our planning, and you can do carrier aggregation if you would like in iBwave design. That's already part of the software. For LTE-U, I know that recently we have been talking to some of the operators globally that are planning for LTE-U in a very high frequency, I think, and we have plans to include it as soon as it becomes a standard, let's say, industry practice. We will include it for sure. Our product management is already in discussions with some of these operators that I mentioned to make sure that we capture all the required information about LTE-U. We have the documentation already, and I think, again, as soon as it becomes a standard, we will be able to integrate it inside iBwave design. It's already part of our plan. As of the moment, it's in the plan. I don't think it's available yet, but again, this is something that I will have to confirm with our product management, and will provide a much more accurate answer during the answer session we will provide. Amna, maybe there was another question that I saw that I have not been able to answer, and I can answer it maybe briefly high level, which was dealing with sectorization of LTE and LTE parameters, how they are considered in iBwave design. I'll touch very briefly on that again, and we'll provide a more detailed answer afterwards. In terms of sectorization, so we discussed it during the webinar. But again, it was mentioned different instances where sectorization is definitely should be part of LTE planning. Again, because of the different user profiles, you have much higher bandwidth that is required, and the only way to meet the demand is probably to have to create the sectorization inside the building or inside the venue, or for a very large venue like a shopping mall or stadium. There are different sectorization techniques. It depends, again, if you're dealing with a stadium which is a very open space, then you know, the sectorization techniques will have to differ from a shopping mall, for example, if it's a little bit more confined area. So again, sectorization can be done in a iBwave design. You can see how the different sectors overlap or how much interference they're causing to each other. All of that should be part of the planning and is taken in consideration in iBwave design. With regards to how LTE is implemented in iBwave design, so again, we mentioned earlier the reference signal. In iBwave design, you have the option of setting up the resource element transmit power, and you have other parameters that are related to LTE planning that should be done based on, so when you choose the system, an LTE system, you have the option of choosing, there are certain parameters that are related to that, and the transmit power of the resource element is also part of that. And again, I will have to open iBwave design and show the detail of how the LTE planning should be done, but again, to be able to do it in detail, we have to take it on a separate call. And again, my team is, I think some of you already met Alfonso Dominguez, our sales engineer covering Turkey. We'd be more than happy to put some of you in touch with him to have a detailed session on LTE if you would like. Thank you, Amna.
Thank you, and those were all the questions we had for today. We are out of time, so I would just like to thank everyone for attending and thank our presenters. If you have any more questions, you can send them our way and we can answer them. Also, feel free to join our LinkedIn group, our iBwave in Building community, where we discuss these topics regularly. So once again, thank you everyone for attending, and I will now end the webinar. Have a nice day.
Thank you.